12. So today we're looking at section 12.1, so the counting principle. The number of possible license plates for the state is too great to count by listing all the possibilities. So it's much more efficient to count the number of possibilities by using this fundamental counting principle. So we're going to look at the fundamental counting principle today. But before we do that, there are some terms that we need to make sure that you understand and know. So an outcome, it is the result of a single trial. So an example would be flipping a coin once results in two outcomes, a head or a tail. Okay, so an outcome would be a head. Sample space would be the set of all possible outcomes. So in one example would be when you roll a die. There's 6 possible outcomes, and the sample space would be the numbers 1 through 6. An event, it consists of one or more outcomes of a trial, such as rolling a die or flipping a coin. In independent events, this means that the outcome of one event doesn't affect the outcome of another event. So like I said, an event is rolling a die or flipping a coin. So in this case, they do not affect each other. So if I were to roll a die and flip a coin at the same time, what I get on my die does not affect what I get on my coin, so they would be independent. Another would be going back to our license plate. The choice of letters and digits are independent because if you notice on this license plate, they got a U as the first one, and then the second one was also a U. So that means when they went to decide the second letter, it was still free to use a U again. So you had all possible options the second time. All 26 letters were available. A dependent event means that one outcome will affect the outcome of another. So this one, they do affect the outcome of another. So example, choosing a piece of candy from a jar and not putting it back, so without replacing it, choosing another piece of candy. One that I always like to look at is if I draw a card from a deck of 52, if I take a card and I hang on to that card, and then I draw another card, well, the second card I go to draw, I only have 51 cards to choose from. So that would mean that I have a dependent event. So let's look at example 1. A sandwich cart offers customers a choice of hamburger, chicken, or fish on either a plain or a sesame seed bun. How many different combinations of meat and a bun are possible? Well, first thing I would ask myself is, are these independent or dependent events? So does what I have for meat affect what I have for bun on my sandwich? No. So I would make them independent. So the choice of meat does not affect the bread. So we want to know how many options there are. First option is to do a tree diagram. Well, I have 3 choices for a sandwich. I can have hamburger, chicken, or fish. And off of that, I can have a plain or sesame seed bun for each one. So I would have 6 total options for sandwiches. If I count up 1, 2, 3, 4, 5, 6. So there are 6 options. This example was pretty small. I only had 3 choices of meat and 2 choices of bun, but it could get pretty big if I had to do a tree diagram for everything. So this is where our fundamental counting principle comes in. If one event can occur in m ways and another in n ways, then the number of ways that both events can occur is equal to m times n ways. This can be extended to 3 or more events. Okay, so if we have 4 events, m, n, l, and k ways, then the number of ways all 4, or options I would have, would be m times n times l times k ways. So using this fundamental counting principle, I go back to my number 1 example. So how many options for meat did I have? There was 3 options, and there was 2 options for bun. So 3 times 2 gives me 6 sandwich options. Let's look at example 2. To check a voicemail, owners may have to enter a 3-digit code. Determine whether choosing each number is an independent or dependent event, then determine how many codes are possible. Well, in this case, if I have 1 for my first number, I still could have 1 for my second number, so that would make this an independent event because my digits can repeat. So I need to go ahead and figure this out. Well, it's a 3-digit code, so I have 3 things. And then I would ask myself, well, how many numbers can I pick for the first one? Well, it's really 0 to 9. So from 0 to 9, how many numbers are there? There's 10 numbers, so there's 10 options for the first one. So that means for my second one, there's also 10 options, and for the third one, there's also 10 options because they can repeat. So I would take 10 times 10 times 10, which I hope everybody realizes 10 to the third. Okay, so either way you type it in your calculator is fine, which is 1,000. So there is 1,000 codes. Let's move on to example 3. Carly wants to take 6 different classes next year, assuming that each class is offered each period. How many different schedules could she have? Well, in this case, we want to know if it's independent or dependent. Well, if you take math first hour, is she going to take math again second hour? Most likely not. So this would make it dependent because she can't take the same class twice. So this, they cannot repeat. Can't repeat the classes, so it makes it dependent. Okay. She's going to take 6 different classes. So I would have 6 options. And for choices, well, her first hour would have 6 choices, then only 5, because she already has a class selected for this first hour, then 4, then 3, then 2, then 1. So I would multiply those all together, and you should get 720. So there's 720 schedules that are possible for her. Okay. We're going to go ahead and stop the video here. There's a little box on your note sheet for you to put any questions or concerns that you have so far. We'll finish up the notes tomorrow in class, and please make sure you go back onto Schoology and take the video quiz. Have a nice night, and I will see you tomorrow.